Okay, we are going to do the same thing here, but instead of doing it with the help of array, now we are going to do it with the help of linked list. So let's say I'm having a linked list. It will have the three part. Let's say the first part will be data. Let's say D. The second part will be priority P, and the third will be the next pointer to its next node. Okay. Again, it will also have the three value. Okay. Let's say 1, 2, 3. Okay. What our head pointer will be pointing? Head pointer will be pointing to this node. Let's say I'm having here a tail pointer as well. So that if I want to add something at the last of our linked list, I can add just after if I'm having the address of tail, I can add after that node. Okay, let's say I want to add something to this priority queue. What I'll do, I'll create a node again. It will also have the three values. Okay, the first, second. So now it will point to its next will be pointing to this node. So at this point, the tail will be updated with this node. So now tail is pointing to this node now, and the next of the tail will be pointing to a null value because it's our last node. Okay, so head will be pointing to this node, as well as if I want to add something, I will be adding at the last of our linked list. And if any moment someone calls DQ function or DQ function, what DQ function should do? DQ function should first check which node is having the highest priority and remove that node. Let's say this one is having the highest priority. So what this should do? Its previous node should point to this node now, and this node should be deleted. Okay. So what you all say? Should I be doing it using doubly linked list or singly linked list? Let's do it for using singly linked list first. Doubly linked list you all will do. Okay. Okay. Arun Vora has to. Okay, just give me 1 minute. Again, my okay. Yes, Tarun, you want to ask something? You've raised your hand. So while you are asking something, I'm going to open another IDE. So here I am going to use a singly linked list. Okay. Chat all this goes. Okay. So if anyone wants to ask something, please raise your hand because my group chat is not invisible for me because I have to at every point I have to just click on this. Okay, just give me 1 minute. I'm setting. Okay, let's leave it. If anyone wants to ask something, please raise your hand. There will be an option of raising hand because I'll get the notification. Then I can see your questions. Let's say at this point, again, I'm creating a struct. Let's say struct linked list. Okay, let's use this time class instead of linked list. So I'm using class at this point, linked list. And what this class is having some public data members. The first will be data, the second will be the priority, and the third will be an pointer of its own type. Means it's own class. Let's say I'm naming it next. Okay. Let's write one constructor for it as well. Let's see if I'm passing some data to this as well as priority to this constructor. What this should do, so this data initialize with data. So this priority initialize with the priority. What this keyword is doing, this is just a pointer that is pointing to this object only, the current object. It will be the prior because in the prior we are having the priority. And its next should be this. Let's say I'm writing this. Next should be null. Okay. So I'm closing this class. Again, I'll be creating a priority queue class. Priority queue. What it is going to have, we'll just have some private pointers. Let's say head. It will not be accessible outside of the class, but only inside of the class. Let's say head and tail. Okay. Now I'm making a public constructor. What this constructor will do, okay, it will initialize head to the null as well as tail to the null because in the initial case head and tail will be null. Okay. So after priority means after we have designed our constructor for both the class, I'm going to design my enqueue function because first we design our enqueue function, after we'll design our dequeue function as well. Do anybody is having any doubt up here? Let me see my chat first. Okay, just remove. Again, I'm sharing my screen. Just wait. Now it is. Now the group chat is visible to me. You can ask your doubts directly. So I'm going to design my enqueue function here. So let's say what our enqueue function will do. Enqueue function will just first create a node because if I want to add something, so I'll be passing some data to it and the priority because we always in the priority queue we pass the data as well as the priority of the data. So what I'm going to do here, let's say I'm going to create a node star. Let's say I'm naming it to new node, locating some memory to it and calling that constructor and passing data and priority to it. So what this line will do, this line will just create a node with the help of this constructor and allocate some memory to it, and with the help of this constructor it will initialize this part of the data with the data as well as the priority, and the next part of this node will be pointing to a null value. Okay. After that, first check because in the initial case our head will be null. If head is null, although if head is null, our tail will also be null. So right now, what I have to do, head is equal to new node. Means now our head should point to this new node as well as because there is only one node into this linked list, tail should also be point to this new node. Okay. And we have updated our head and tail because head is now pointing to this new node, tail is pointing to this new node. Our rest work is over. So I'm returning from here. If head is not equal to null, this means there is something in our linked list. Let's say before adding something, let's print n statement again, inserting so that I can see in the output tab, inserting data with the priority the priority PRI. I'm writing ENDL. ENDL is just for the line change, the end of line. Okay. So if head is equal to null, if head is not equal to null, then it will come to line number 37. Let's say. So it means the last is pointing to the last, means okay, we have tail pointer. Tail is pointing to the last node. So what I'm going to say, tails next should point to now new node. You all know new nodes next is already pointing to a null, so we don't need to change that. And as well as now our tail is new node. Okay, our rest work is over. Means we have added one node successfully. Now what we are going to do here, we are going to design a dequeue function. Dequeue will not take any argument. It will first check whether there is something in our linked list. Let's say because we have not checked in the case of this, means because we are using dynamic memory allocation, and in the case of linked list we don't check, means whether our queue is full or not. I have a doubt in the queues with the linked list, that is when a NQ first, okay, when NQ first element front is equal to new node, rear is equal to new node. After that, for other elements, rear dot next is equal to new node right. Yes, but when we traverse, we start from the front node. My doubt is front dot next is never linked with the other elements, but I'm able to traverse the whole list because let's say, let's try to dry run our code. Okay, Nani, I got your doubt. Let's say in the first case, what will it have? Means in this case, uh, if there is nothing, we'll create a node here, and we are saying now our head as well as tail is pointing to this node. Okay, because in the starting case head as well as tail is pointing to this new node. So after that we are saying return from here. If again I want to add something, after that head is not equals to null. Okay, so what I'm saying, tails next should point to now new node, because tail is already pointing to this node. Tail and head is right now pointing to the same node. So I'm saying tails next should point to this new node. Let's say this new node has been created here. I'm saying tails new node should point to this node, and instead of tail pointing to this node, now points to this node. Okay. Again, if somebody wants to add something, add one node here, and I'm saying because at this point as well head is not null, so tails next should point to this new node. So now its next should point to its new node, and tail should point to this new node instead of that node. What we are seeing here, what you are saying, we have not means linked with front dot next, because in the first case we are saying uh, in the second case, means after first element has been added, if after that we want to add something more, so in that case front and means head and tail is the pointing to the same node. So I'm saying tails next should point to its node, this new node. So if we want to traverse from head, head is pointing to this node, head's next will point to this node, its next to next will point to this node now. Okay, so I got your point, means you are saying we have not never linked with linked our new node with the heads next, but in the initial case when we are trying to add our second element, in that case our head as well as tail pointer is pointing to the same node. So in that case what we are saying, tails next should point to that new node. So it's the same thing if we say heads next should point to this new node. Both are the same thing. Danny, I think you got my point. Is that fine now? Because you have written a very long doubt. I think I'm able to understand. If not, please do raise your queries. Please do let me know. I'll try to answer it again. Okay, that's good. You got it. So let's come to our topic again. Okay, someone is trying to unmute him. anybody wants to speak something, you can let me know. I'll unmute you, and you can share your, if you're having anything to share or you're having any doubt. Okay. So in the DQ, I should be having something first, means I should be having something if I want to DQ something from a queue. So what I'm checking, if head is equal to null, although I can design a is empty function as well. So I'm not designing that function, I'm just writing it here only. If head is equal to null, what it means, our priority queue is empty. Okay, and I should be returning from here as well. If it is not null, then means there is something in our linked list, and I want to delete a max, means a data that is having the highest priority. So what I'm going to do here, let's say first I'm creating a link, a temporary node that will store the value of head, because we cannot alter the value of head into this class, means for this object this will be the change, means it will be change for this object. So I'm storing the head of means the address of head into the temporary variable, as well as I'm creating maximum vary, means a maximum pointer. Let's say I'm naming it to a maximum. This maximum pointer will store the value, means store the address of that node that will be having the highest priority, that will have the value of the highest priority. Okay. So in the starting, let's say I'm saying you point to this head node, or we can say just point to null. Okay, we cannot point to null because in the starting case we are going to means compare it with the someone with some value. So I'm saying in the starting case, let's store the value of head only. Okay. So now what I'm going to say, while the temp is not equal to null, if temp is not equal to null, what you need to do means if temp is not equal to null, then perform this while loop. And the while loop, what I'm going to check whether max p's priority, means max p's pri, let's see the value, the priority value that is having at the max p, if it is less than the value at the temp pri, to update the value of max p with the temp. Right now, if some we found some node, if its priority is having the value, means having greater value that max p's priority, update that max p, and now max p should point to this temporary node. Okay. So now, as well as perform temp is equal to temps next. Okay, keep on performing this. So if we come to line number 59, what it means, it means in the max p we are having the address that is having the priority, highest priority value. So in the first case, let's say if there is only one node, means if there is only one node, so what we need to do, we just need to check for the that condition. If there is only one node, let's say head equals to heads next is equal to null. Let's say heads next is equal to null. What it means, it means that there is only one node, although I can do it here, means after this line as well. If there is only one node, we should be deleting that node. Let's say I'm trying to do it here. Okay. Before doing that, let's say I'm trying to, if there is only one node in the max p, the address of that node will be stored. Let's say I'm saying deleting max p's data with the highest priority, because the priority value that is having at the max p's priority, it will be the highest priority. Okay. Say I'm writing end here. Okay. So if heads next is equal to null, what it means? Let's say if heads next is equal to null, there is means it means there is only one node. So what I'm going to do, delete head and delete head, and now head should point to the null, as well as because there is only one node, there were only one node there. We have deleted that node. We should be what we should be doing. We should be updating our tail node as well. It should now point to null value. Okay. So what Ashish is saying, line number 55, max p, okay, max priority is equal to temps priority. No, Ashish, what I'm storing here, I'm storing the address of that complete node, so that if I want to delete that node, I can directly delete that node. Means what we have to iterate as well, but I'm not changing. Means although if you want to, means if you want to change the priority of that node, means if you want to change store the maximum priority value, you can do you can use the int variable as well. Okay, but if I right now what I'm having the in the max p, I'm having the address of, let's say this node is having the maximum priority. So in the max p, I'll be having the max will p will be pointing to this node now. So if I'm having the max address of max p, so here I can print that the data of max p will be the data, and the pri of the max p will be the priority, that highest priority. Okay. Okay, if what I'm doing here, deleting head is equal to null, tail is equal to null, as well as if head is equal to null, tail is equal to null, return from here. And what we have to check also, now what we are going to do, we are going to perform and while loop, and let's say this node is there. If I'm having the address of this node, if I want to delete this node, because this is the singly linked list, we cannot go to this node. So I should be iterating first. If its next is equal to max p, if its next is equal to max p, I should be stopping here, and its next should now point to max p is next. Okay, is that clear with everyone? Let's say I'm iterating a loop. If some let's say its node is there, the head is there. If heads next is equal to max p, if heads next is equal to max p, what we need to do, we just need to update heads next with the max p is next, and we need to delete the max p. And before doing that, what if max p if max p is means pointing to this head node, so we cannot do that. Let's design the case for that as well. If max p is equal to head, what you need to do in that case, let's say the node is having the first, means if it is the first node, so what it needs to do now, head should be heads next, okay, and delete max p. Is that clear with everyone? Delete max p and return from here. Sure, there will be some data after heads next. If heads next is equal to means heads next cannot be null, because if heads next is equal to null, we have already implemented a case for that. So it's if it's next is equal to null, head will be null, tail will be null, and it will return from here. It will not come to this line. Okay. So if max p is equal to head, so we have already, if there is only one node, we have already implemented the means we have already implemented the case for that. If there is only, if the max p is pointing to this head, we have also implemented the case for that. So now we can say that while now let's say again, because temp in the in that case, in this from this temp will be null. So again I'm saying temp again point to our head node, and I'm saying while temps next is not equal to max speed. If temps next is not equal to max speed, do temp is equal to temps next. Keep on performing the next of temp. When this loop will break, when it comes that temps next is null. Let's say temp comes here, and this is the max speed current right now pointing to this node. So now temp will be pointing to this node. So what I'm saying, temp should point to now temps next, because temps next is max speed. Now temps next should point to max speed next. Okay, and delete that max speed. Done. Okay, let's quickly design our print function. I have to close my class here. Okay, let's quickly design our print function. Void print. Let's create a temp variable here. If anybody is having any doubt in that code, please do ask while I'm writing my print function. I hope the print function will be clear to everyone because it will be a simpler function. What I'm saying, while temp is not equal to null, what you need to print, you just need to print temps data. Just print data, temp data, priority, temps PRI. Okay, write an statement here as well. See out printing printing. Okay, Realme is saying no doubt. That's good. Okay. Others, while see the code, and if you're having any doubt, please do ask. Printing the value of the priority queues. Priority queue. Say slash. Okay. And before printing, let's check whether there is something in our list or not. Although it will not cause any error. If head is equal to null, print an statement that cout queue, let's say priority queue, it's empty, return from here. Okay. If head is equal to null, then the priority queue is empty, and print an statement then and return from here. Okay. So we have designed our in line number 97 correct head. Okay, Sri, thank you. Means I have some syntax error. Okay, HEAD. Okay, thank you, Sri. So let's quickly try to run our function. Let's see whether we have implemented everything right or not. So again, priority queue is there. Let's say priority queue q.enqueue. Let's try to enter 10 with the 5 priority. Let's try to enter q 20 with the priority 8. Let's try to enqueue 30 with the priority 7. Q enqueue 30 with the priority 39, 40 with the priority 9. Q enqueue 50 with the priority 4. Okay, let's call our print function first. Let's see whether we have inserted everything is fine or not. Let's see whether it is running or not. Okay, warning, time limit exceed. Okay, let's check whether we have implemented everything right or not. So can somebody tell me what the error we are getting? Okay, with this is not the error. So what it is saying that create a node, and if head is equal to null, head is equal to new node, tail is equal to new node, and return from here. And tails next is new node, and tail is equal to new node. Okay, fine. Means NQ operation is running fine. Let's comment our DQ operation. Let's see whether now our NQ is running. Okay. I hope, I think I got the error. I think in the print case I have not written here that temp is equal to temps next, because it will cause a time limit exceed. Because this will never come. This while loop will never end. Let's now try to print our function. Okay, that's good. Inserting 10 with the priority 5, 20 with the priority 8, 30, and we are seeing the data, the same data, it's being inserted. Okay, let's try to dequeue some data from our queue. Let's see which one is having the highest priority. The data 40 with the 9 highest priority. Let's see whether the 40 is being deleted or not. Okay, deleting 40 with the highest priority 9. Okay, let's try to delete one or two more element. Let's see whether it is working fine or not. Okay, deleting 20 with the highest priority 8. It means that we are getting the correct output. So is that clear with everyone? Means today's code. Although STL has also provided us that priority queue, STL uses the heap. So in the next week, when we are going to, means in this week, we'll complete this linear data structure. And in the next week, when we'll start with the heap, we are going to means discuss the max heap means and the priority queue of the STL there. Okay, we'll discuss in this the STL of that priority queue in the next week. Once give high priority to 50 and DQ once give high priority to 50. Okay, you're saying once give high priority to 50. Let's say I'm writing it 14 and DQ and again NQ. Okay, after DQing, let's say after giving it to highest priority 40, I'm trying to NQ something. Okay, let's NQ 45 with the priority 8 with the priority, let's say 3. Okay, so Danny is saying that insert 50 with the highest priority. So 50 is having the highest priority 14, and I'm dequeuing that thing and I'm NQing one more element after that. Let's see whether we are getting the output right or not. Okay, so 50 is being deleting 50 with the highest priority 14, inserting 40 with the priority 3. Let's say 45. Okay, inserting 45 with the priority. Okay, so 45 is not being inserted. Okay, let's see whether we have done wrong. Inserting 45 with the priority 3. Okay, the statement is being printed but it is not being added. So it was the last case. Okay, I got your point, Henny. So what is happening in this case when we are trying to delete the last element? So where are DQ function? Let's add one more case here. That's good. Then you have created this test case. So what is happening? If that max p is pointing, if it is equals to that tail, if it is equals to that tail, because we have not updated our tail if it is the last element. So instead of doing it here, do it here. If max p is equals to tail, what you need to update tail with the temp. Okay, is that fine? Will that work? Let's see, because now I'm updating my tail with the temp. Okay, so 45 is being added. What I'm doing it here, so I'm just checking in the last case if max p is equals to tail, if it is the last node. So what you need to do, you just need to update your tail as well, because temps next is the value maximum, means the temps next is the max p. So if max p is being deleted, so update tail with the temp. So now tail should point to the temp value, because temps next is right now null, because max p's next was null. So temps, because max p was the last element, temps next is max p's next. Max p's next was the last element, and max p's next was the null. So now temps next was the temps next is null. So in that case, what I'm saying, tail is equal to max p. Sorry, tail is equal to temp. Update the tail as well. Okay, Danny, I